It might sound like science fiction, but the three dimensions of space we are used to might not be the only ones out there. One theory of particle physics suggests there are in fact 9 dimensions, and black holes might be the key to reaching them. This means that black holes could be portals to other universes. Now scientists at the Large Hadron Collider are closing in on the hunt for evidence. A few theories in particle physics suggest there is much more to our universe than meets the eye, and these extra dimensions could answer questions ranging from quantum physics to gravity. One of these, called brane theory, suggests multiple dimensions could be hiding extra universes. Brane theory is part of a larger theory called string theory, which attempts to explain how all the forces and particles we see fit into one single description. Dr. Chris White, a physicist from the Queen Mary University of London, told Mail Online it suggests that the basic building blocks of nature, instead of being particles, can instead be strings, planes and higher dimensional generalizations collectively called branes. The equations of string theory, which necessarily includes branes, only make sense in 9 space dimensions rather than the 3 we appear to observe. Strings live in a 9-dimensional space, and when time is included as another dimension, this makes 10. In his book The Universe in Your Hand, Dr. Christoph Galford describes a thought experiment that shows what it might look like if we were able to travel between these dimensions. You see what you think might be black holes linking nearby branes through a tube of distorted space-time, with gravity from each brane attracting others, he said. You suddenly wonder if, by any chance, there might be other people living in those branes. Could their black holes be a passage between your world and theirs? Using the Large Hadron Collider at CERN in Geneva, researchers are looking for signs of extra dimensions, and one of these is tiny black holes. The LHC could make small black holes if there are extra dimensions of the right size, Dr. White added. These would decay very quickly but leave a dramatic burst of radiation in the detectors. There are a few problems with our current understanding of physics that point to the idea of more dimensions. For example, why gravity is so much weaker than all the other forces. A small fridge magnet is enough to create an electromagnetic force greater than the gravitational pull exerted by planet Earth. One theory says we do not feel the full effect of gravity because part of it spreads to extra dimensions. Theories suggesting extra dimensions predict in the same way as atoms have a low-energy ground state and excited high-energy states, there might be heavier versions of standard particles in other dimensions. There are also extra symmetries needed to get string theory to work, something called supersymmetry, and this also predicts new particles, Dr. White said. So searching for these particles is one way the LHC hopes to find evidence. Evidence for extra dimensions could also be found in the creation of microscopic black holes. But if proof of extra dimensions is discovered, it would not necessarily mean string theory or brane theory is correct, and some are not so convinced they exist at all. Right now I don't see any strong convincing arguments for thinking there are other universes, said Carlo Rovelli, a theoretical physicist at a Royal Institution debate in July. But the LHC continues to search, looking for these microscopic black holes and any new kind of particles. Positive results depend on there being branes or extra dimensions at just the right energy that the LHC can see them. Dr. White said, if the LHC does not see anything, it instead rules out the presence of extra dimensions or supersymmetry below a certain energy scale. New constraints have been regularly published since the LHC started and reported at international conferences. If found, these dimensions could contain other universes. Exactly when the LHC might find this kind of evidence is not known. We cannot predict when we will have results, a CERN spokesperson told Mail Online. But you can be sure, as soon as we have one result to one of the above questions, we will certainly tell the world.